So today we are going to combine breakout strategy with a machine learning or AI model, like a decision tree model, and see what we get. And we've got a substantial great result from this strategy, and we have tested it over multiple stocks. So it's basically a portfolio backtest, so we can avoid any kind of selection bias in the strategy. And what basically the strategy does is that it takes a normal breakout strategy, which any trader out there uses, and it filters out any kind of false signals via using this machine learning or AI model. So for example, here, let's take the case of Google here. So Google has got many breakouts. Like here, for example, it's got a breakout here and came down. It's on a weekly chart. But again, there's a breakout here and went up. So basically what the machine learning model is going to do, it's going to take in some input features. So it could be the volume, because that's generally what the trading community uses. It could be volume, it could be gaps, it could be the length of the bar, it could be anything. You can feed in anything with a machine learning model, and that's the beauty of machine learning strategies. That you can feed in lots of input features, and it will take the most important input features necessary for this strategy to be beneficial. So we're going to do a training and testing data. We're going to split the training and testing data into completely different sections, so we don't have any curve fitting. And obviously, like I said before, we're going to do it over multiple stocks, i.e. portfolio testing. And our goal is not just to get returns, higher amount of returns. Our goal is to get returns, but also to protect our portfolio from going bust. And our fundamental goal is to beat the S&P 500 buy and hold CAGR to maximum drawdown ratio. So that's like 10% divided by minus 55. That's 0.18. So for this strategy, what we're going to do is we're going to use a machine learning model. So the machine learning model that we use is a decision tree. Now, again, I've discussed the decision tree model multiple times before, but if you want to have a thorough understanding, there's a video here using AI decision tree model to trade stocks. So in there, you would get a complete understanding of how a decision tree model works. And it's very imperative that you actually do study what a decision tree model does, because once you know the decision tree model and how it functions, then you'll understand how effective it is in applying the strategy. Okay, so let's go into the training and the testing methodology that we're going to use. So generally we use a fixed window training. So that's basically you train from a fixed time period. Let's say that's from 2000 to 2010. I've gone through this before in the previous videos, but still just to get a rough idea for you guys to understand. So from 2000 to 2010, you're going to train it. And in order to test it, you're going to take a period which is a completely different period and see whether it works on that testing period. So while choosing the training period, you have to be careful. You have to make sure that the training period does contain some kind of a black swan event. So for example, in 2010, you have the dot-com bubble and also the global financial crisis, which are all very significant events in the financial markets, and that can really give you very good training in the model, and that model does survive any kind of black swan event. So for example, if the 2020 crash did happen, or whatever volatility situations happen in the testing model, you can understand that this model does work. So that's the normal traditional fixed window training, and that can be used in many strategies, and we do use that strategies. But then there's also another one, and that's called sliding window. So sliding window, what happens is that the training and the testing period keeps on changing. So for example, if there is end period of training, and then we test it, and then the training moves to the most recent period, and then it tests the next period as well. So to make you understand in a very simple term, so for example, let's take this case of this example here. So we've taken 60 days and 30 days. In the strategy, however, we have done 80 and 30. We'll discuss that in a bit. So for example, here we're going to train from April 1st to June 1st. So that's 60 days. And then we're going to test it from June 1st to July 1st to see whether it works. Right, and when July 1st happens, then we're going to train from May 1st to July 1st. And then we're going to test it till August 1st. You can see that training data keeps on changing. So what it achieves is that it achieves the whole idea of adapting to recent market movements. So what that helps you is that any kind of market evolution taking place, the strategy gets evolved accordingly. And thus you get an additional edge in trading from that specific evolution. So again, breaking down in a table form, for example, April 1st to May 30th will be the training, and the testing June 1st to June 30th. And then on July 1st, May 30th to June 30th will be the training, and then again, the testing bit. So this is basically what a sliding window is. Now, just like I said, the sliding window has advantages. It has also got disadvantages as well. So we're just going to break it down here. So you can see the training is got fixed for the fixed window. In sliding window, slides forward is retrained on the most recent data. On the testing part, again, the testing is fixed. For the sliding window, testing follows each new training period. Now, the adaptability part is where it makes a huge difference. So, fixed window, the adaptability is low. You have to manually change it. So, for example, you did it from 2000 to 2010 and you've trained that model. So, there is a certain day would come in where you have to be like, okay, you know what, I need to change that training. I need to add additional trading months into it so that the model gets trained much better. So there is that manual execution of adaptability. However, on the sliding window, it keeps on adapting to newer market. You don't have to worry about manually changing it. It keeps on adapting to the recent market conditions. Now, what's the use case scenario? So for use case, the best situation for longer term trading would be basically a fixed window. So if I can feed in the black swan events like the .com or the GFC, then basically it kind of takes care of any black swan events. So some strategies I can do a fixed window and some strategy I can do sliding window. Fixed window learns a lot. So for example, here we are only learning 60 days and then testing it on 30 days. On a fixed window, the learning is much more broader. It's learning over 10 years of data or n amount of years of data, so it can learn a lot, and because it can learn a lot, the model can be much more effective. And again, it's like I said before, it's good for black swan events. Now, sliding window, it doesn't have to be long term, it can be short term or whatever. It's adaptive. But it's got a big red flag. It may not be black swan proof. So because in this model we have decided like 80 days or 30 days, 60 days and 30 days, what happens is there's no black swan event in those 80 days, right? So when that black swan event happens, this model will kind of not perform that great, and it's kind of like a delayed adaptability. So it's only after 60 days or 80 days that the new learning has taken place to the model, and then the model is like, okay, fine, we have the situation, and because of that we will adapt to the market conditions. So it is sensitive to recent market events and it is blind to historical tail risk. So these are some of the things that we can achieve do with a sliding window. And sliding window, and compare when we do it across, so when you do it from 2010 to 2020 or something, you have multiple sliding windows, multiple training and testing data, and when you have so many of those things, and also when you have a portfolio level back testing with lots of stocks without any selection bias, and that in that way you are achieving reducing the curve fitting as much as you can. Okay, so this is one of the biggest advantages of quant traders. It's boring and mechanical. You're just inputting some strategies in there and you're achieving the diversification, and you're applying proper stress test over the recessionary period. You're trying to check it during the periods whether it works or not. And because of this, the fundamentally quant traders have a fundamental edge over retail traders out there. So let's go into the strategy here. So we're going to look into the strategy codes before we see the results of it. So basically we're just importing the libraries, and Quant Connect has got a decision tree classifier library. And we import the decision tree classifier, and then we also import the standard scaler, which we are going to use. So the entire code is available for our quant program course students. You can check them out. It's in the machine learning and AI algorithmic trading strategy, and we have got multiple amount of machine learning models, and all the machine learning models are fundamentally designed to beat the S&P 500 CAGR to drawdown ratio. So these are some of the results of these strategies. So we've got linear regression model, we've got decision tree, we've got another decision tree model, we've got support vector machine, we've got a recurrent neural network, long short-term memory. We also have discussed combining machine learning models. So for example, here is RNN plus regression, and then here's RNN support vector machine. So these are some of the strategies that we have created for you guys to understand. So let's go back into the code, and then we create a class here, and then there's a def initialize function. So again, you are assumed to know some idea about Python. If you don't know anything about Python, then I would say you can go into this video here, algorithmic trading 0 to hero in Python. It is a very thorough beginner tutorial for you guys to get to know about Python. And then if you want, you can go through the Quant Connect tutorial as well, but that won't be necessary. You can just read in through this class and these functions and you will understand what the code does. So basically we have set a start date, and we've got a end date I've commented out because it's going to test on the most recent data, and then the cash and the capital allocation. So here what we're going to do is we're going to do 5% allocation. So every single time there will be 5% of the portfolio allocated to a single position. So maximum amount of position at any interval will be 20 positions. So 20 into 5, that'll be 100% portfolio allocated. And then basically simple data, what data we are importing. And then we have got the random seed. So the whole idea of this random seed is that when you create a AI model, like a decision tree model or any kind of AI models, the results can be different slightly because during the training, they initially check like a random variable. They take in a random variable weights, and then they keep on training on it and coming to a conclusion. So sometimes the final result might be slightly off. So for example, if it's like a 10% CAGR, maybe you might get like 10.5% or 11% CAGR or 9% CAGR. So it can be a slight difference. So in order to make sure that every single time we get in the similar results or exact results, that's the reason why we use a random seed of RP NP random seed 42. Now, if people don't know what 42 is, the why coders use 42, you can browse online and find out. There is a story behind the number 42, so you can go into ChatGPT and find out why it's used by coders a lot. And then basically we are just adding SPY because we'll be using SPY as one of our filters to enter. And we're going to calculate the moving average, and we are going to create a universe of stocks. So we're going to create a universe of stocks based on certain conditions that we like. And then we're going to warm up and basically create a model to train. We're going to use rebalancing, and we are going to use that information to train our model. So as you can see here, we have used decision tree classifier, maximum depth 5, and random state 42. Now you could basically make lots of changes to this decision tree classifier, and that's essentially what's called hyperparameter tuning. So if you can go into the course material and go into hyperparameter tuning, and then the PDF there, you can get it on. Okay, so you get to understand what kind of hyperparameter tuning you could do from what impact it does. For example, max depth pretty much creates a splits in the tree, which you will obviously understand when you watch a video on the decision tree. And then how much of an influence it has on prediction of these models. Similarly, there are other hyperparameter tuning you could do, like some of the things are the minimum sample splits, minimum sample leaves, things like that. And then if you can go back and then you go through the decision tree lecture, and here you would basically see like a challenge or something. So you can fine tune it based on the maximum depth change to 3 and also add in the minimum sample split change. So the whole idea of all these things is to push you to keep on changing the models and see what significant impact it makes it to the strategy. And then things like, change the outperformance to QQQRUA instead of SPX, increase the training duration days, see what the output for that is. So instead of 80 days, you can do like 100 or 150 days, and increase the testing days as well. And the other things like the quizzes, the whole idea of the quiz again is for you to make sure that you understand what each part of the decision tree model, what makes a significant impact to each of the model. And when you go through the course notes and the course lectures and the hyperparameter tuning and then go through the codes, you will pretty much be equipped to understand these questions and then make changes to the codes in such a way to enable you to make the strategy significantly better than what you got here. So treat this code more like for boilerplates, and from there you kind of build up on it on what you have learned. Okay, so now let's go back to the code that we are discussing here. A standard scaler is basically just a function, because sometimes you get numbers like an RSI value is different from a price value. So in order to like standardize it, we use the standard scaler function. So what happens after the standard scaling is that it will have a mean of 0 and standard deviation of 1. So the whole idea of that is like sometimes, let's say for example, there's like a big number, like a huge number, like 15,000 or something, as compared to like a RSI which is like 20 or something. So the model might give significant importance to the bigger number. So in order to avoid those kind of situations in the model, we need to have some kind of weight, some kind of importance to each number. We can't give like a bigger number more importance. So that's the whole reason of why we use standard scaler. And then basically we have used whether the model is trained or not, because once the model is trained, then we can execute the strategy. So this is basically where we decide which stocks to trade. So as you know, liquidity can be a big of an issue, and slippages can be an issue. So what we're going to do is we're going to find the best liquid stocks. And one of the best ways we can find out the best liquid stocks is by using the dollar volume. So basically what this does is that it checks if the stock is fundamental data, and it checks the dollar volume of it, and it sorts out the top 100 stocks, and we will only be investing in that top 100 stocks. So the 20 stocks that we will be going in. That will be from the basket of 100 stocks. Then these two function here is basically just to remove those stocks or add those stocks based on the dollar volume. Now, this is the on data function where we will decide when to enter the strategy and when not to enter the strategy. We will be running the train model function. And as you can see here, the time delta is 30 days. So every 30 days, we will be retraining the model. And let's go and see where the model is now. So here's the training model. And we are going to do 80 days. So remember we said 60 days and 30 days here. So instead of 60 days and 30 days, we'll be doing 80 days in this specific model. You can keep on changing whatever you want. You can make it 90 days, you can make it 100 days, you can make the testing much more longer as well. So it depends on you. So what the training model in summary does is that they look back 30 days and they compute the features, the input features that we feed in, which is kind of hidden in this code in this video. So that can be something like the gap. So it could be the volume, it could be the price, it could be anything that you feed in. It can be multiple things, or it could be like simple one or two things as well. And then it basically checks what happened in the next 10 days, whether the stock kind of rose 3% or whatever. And then based on that, it uses a label, yes or no, 1 or 0. And this collects these training examples for all the stocks that we trade. And then we scale them using the standard scaler. And then the decision tree predicts whether the stock is likely to rise greater than 3% in the near future based on its past features. So that's in summary what the training model does. And then basically we are going to give out this information to the entry and exit scenario, which will be here. So we are prediction, if the prediction equals 1, then basically enter the strategy. So here we have got the high as the 50-day high. Again, you can change this to 100 days or 20 days or whatever. So that will be one of our entry conditions. That's a breakout, basically what we're discussing here. So breakout will be 50 days. And then we also check if the S&P 500 is also trading at a good place. And then the prediction of the machine learning model will say whether to enter or not. And that's it. So now let's go into the results of this strategy and see how it has performed. So it's tested from 2010 to the most recent date. That's 15th of September, and then we have got a brokerage fee of $1,800 something, and we've got a return of 1,700. So let's go into the minor details of it. So these are some of the stocks where the trades have been done. So you can see it's all big names like Pepsi, Microsoft, Netflix, Shopify, Facebook. So they're all the liquid companies out there, and that liquidity gives us a fundamental edge in this situation, this strategy as well. So let's see the CAGR. So CAGR is 20% and drawdown is 33%. So let's do a CAGR to drawdown ratio of S&P 500, which is like 10. The maximum drawdown was 55. So 0.18, as we discussed before, is the one that we are trying to beat. So now let's see it on this specific strategy. So that's 20.5 divided by a maximum drawdown is 33%. So 33.4. So we've got 0.61. So this has performed spectacularly well, this specific strategy from a CAGR to drawdown, maximum drawdown perspective. So what we use to compare strategy performance is CAGR to maximum drawdown ratio. Now, I'm not going to go deep into it on why, because I've discussed this in the previous videos and also done a blog article. But I would suggest that you go into ChatGPT or any of the favorite LLM models and kind of write in why CAGR to maximum drawdown ratio is a better performance measure as compared to Sharpe ratio, and you will generally get an idea on why that is the case. So hopefully you got a general idea on how we have designed this strategy. The code is pretty simple. We have put it into different sections. The first section is just creating and initializing different things, creating the decision tree classifier and the standard scaler, and then creating a basket of stocks where we will be putting the trading in. And then obviously the basket has to change based on the liquidity. And then obviously we are going to train the model. And once we train the model, then we're going to basically give out that condition along with the breakout condition to enter, and then we will enter the strategy. And that's it. It's a very structured code. And these are some of the many approaches you can do with machine learning. So one thing you shouldn't do in machine learning is just use machine learning or AI just to predict prices, just to create the direction that you're going to trade, but rather you should have an existing strategy which has got a certain amount of alpha. So this strategy, this breakout strategy, has got a little bit of alpha. The machine learning is just making it go slightly further and creating a better results net. And that's what the whole idea of using machine learning and AI should be. I see many people out there just using machine learning and AI to trade. That alone is not a good idea. You have to combine it with some kind of value based approach. So when you have an edge, like for example, you have like a 10, like 15% strategy or something, and if you use the machine learning or AI model, you can possibly increase that 15% CAGR to maybe 17% and possibly reduce the drawdown from like 35% to maybe 30% or 25%. So if you have any questions or doubts, let me know in the comment section or through email, which you can find in the About page. I'll be happy to respond if we have the time. So hope you have a good day. Thank you. Bye bye.